there is an equation that we need to learn how to work with called the slope-intercept equation, and it is an equation that is used with linear equations. The slope-intercept equation of a straight line is y equal mx plus b, where x and y are variables. The m, hence the name of this equation, the m is going to represent the slope of the line, and the b is going to be the y-intercept of the line. Whenever a linear equation has been solved for y, in other words, when the y is isolated, then what results is this form of a linear equation. When the equation is written in this form, as you can see here, it is easy to identify the slope and the y-intercept for that particular equation. For example, if I had y equaling 2x minus 3, I can quickly look at this and see that since the coefficient of the x is 2, then the slope of this line is 2, and the y-intercept would be at negative 3. This can easily be verified by graphing. If you go to your graphing calculator and put in the 2x minus 3, hit a zoom standard, what you'll see is a line being drawn. If you hit the trace button, you can see that the y-intercept is negative 3, and the slope, even though it's hard to see on this particular type of graph, see that it is exactly 2. It is a positive slope, an uphill slope like we anticipated. Now let's look at another example. Let's look at y equaling an x plus 7. Here the coefficient, even though it's not specifically written, the coefficient of x is 1, that is, as in that is 1x. So your slope would be 1, and your y-intercept would be 0, 7. And we can go back to the calculator, put in the x plus 7, and when we graph it, we see that it's not as steep as it was before. We can trace to see that the y-intercept is in fact 7, as we anticipated. So when the equation is written in this form, the slope and the y-intercept are easy to see. But you will find the equation not always written exactly in this form. If the equation was written as 4x minus 3y equaling 15, we cannot immediately look at this and tell what the slope and the y-intercept is going to be because it's not in the correct form. We will first subtract off the 4x, or add a negative 4x if you want to look at it that way. We'll have a negative 3y equaling negative 4x plus 15. We can divide off the negative 3, and we get y equaling, and you need to reduce and simplify wherever possible, even if it's nothing more than canceling out two negatives. Make this a 4/3 x minus 5. And again, on the calculator, we can put in the 4/3 x minus 5, and when we graph that one, we see a positive slope, and we can see the y-intercept negative 5 exactly as expected. So from this equation, you can clearly and easily pull out a slope and a y-intercept. And we can also use that to graph. If I had a 5x minus 3y equaling 12, I could once again solve for the y. I'm going to divide here in my last step, and we get y equaling 5/3 x minus 4, and I could graph that by hand. It's easy enough to see the calculator do it, but by hand I would graph this by starting out at -4, because that is the y-intercept, and from the -4 I would come up 1, 2, 3, 4, 5 over 1, 2, and 3. That would be the next point, and that's how I would draw it. Now, most of the slopes we have seen have been positive ones, which means you come up and right. Now, if you're dealing with a negative slope, let's say we wanted to graph, instead of a positive slope, we want to graph something like y equaling -2/3 x plus 1. Well, we can clearly look at that and easily see that the y-intercept is 1, so I'll put a dot there. And the slope is -2/3. And the negative is going to be associated, and you're going to always want to let the negative be associated with the numerator. In other words, from this point, the -2/3 means come down 2, and then over 3. So we're always going to be wanting to move to the right. The negative is just going to imply down as opposed to up before we move right, and that gives us a downhill line exactly as we expected. And we can also take a pre-existing graph. Since we now know how to take the equation and graph it, we can take a pre-existing graph and use that graph to come up with the equation that generated the graph. So we're going to draw a graph here. And here's our line. So we can already see that we're going to have a negative slope in this one. Here's what we need to be given. First, you need to be able to see where it hit the y-axis. Let's say it hit up at 5. You're also going to need to be able to see one more point on the line. Let's say we're given the point 2, 3. All right, from this, we can imagine a right triangle here. We can find our slope. Our y values went from 5 down to 3, 5 minus 3 being 2, and our x's went from 0 to 2, 2 minus 0 being 2. Our slope is going to be a negative, as in downhill, not up, -2 over 2. Our slope is a -1. So we can take this information, put it back into our equation, and say y equal -x, or -1x if you want to call it that, plus 5. That would give us the very line that we see drawn here in front of us. So from an equation, we can come up with the line. From the line, we can come up with the equation. And we can also use this form of the equation to come up with the equation of a line when certain information is given, whether you have the drawing in front of you or not. Let's say, for example, that we are given that the slope of a line is 4, and the line passes through the point 2, 3. Can we come up with that equation? Well, we've got this much. Y equal 4x plus, and b is unknown. Now, at this point in time, some books would have you use something called the point slope formula, but that formula is actually unnecessary, because if the slope is given and a point is given, all it's missing is the b. So since the point constitutes an x and a y value, I'll simply make those substitutions. 3 equals 4 times a 2 plus b. 3 equals 8 plus b. Subtract off the 8, and you'll see b is -5. So that means the equation is y equal to 4x minus 5. Let's try that again. Let's say we had a slope equaling a -2/3, and we want the line that has that slope, and passes through the point 9, -2. Let's come up with the equation. Again, here's what we already know. Y equal -2/3 x plus b. We know this is an x, and this is an example of a y. We'll put those numbers in place. We will multiply, and -2/3 times 9 is a -6. And we're going to add 6 to both sides. We find b to be 4. So the equation that fits this is y equals -2/3 x plus 4. So from a slope and a point, it's easy enough to come up with the linear equation. And we can actually do it in certain situations when the slope's not given, because we know a way to find the slope. Let's say we want to find the equation of a line that passes through the points 6, 3 and 5, 2. The thing we had before that isn't given this time is slope. So we need to find it. This will be our x1 and our y1, our x2 and our y2. We can use our slope equation and say that y2 minus y1 over x2 minus x1 is a -1 over -1, which reduces to 1. Now we go back to what we were doing last time, back to the point where slope was already given. Say y equal to a 1x plus b. Of course, the 1 writing it in this equation isn't actually necessary, but just to show you where it came from. Using the ordered pair of your choice, y equals m times x plus b. Subtract off the 6 in this case. And you can write your final answer. So even if the slope isn't given, if you're given 2 points, you can use the slope formula to find it, and then go back to doing it the way we before. Now, one other thing that this equation is good for. It is easy to use this equation to see when lines are parallel versus perpendicular without actually having to draw them. Let's say I had 2 equations. A 5x minus 6y equaling 10, and a -6x plus 5y equaling 20. In each one of these equations, I'm going to start out by solving for y. Here I'll divide off, and I've got y equaling a 5, 6x minus, I'm going to go ahead and reduce this fraction, minus a 5/3. So for this particular equation, I can see my slope is 5/6. If I get a 5/6 over here, I can say these are parallel. If I get a -6/5, I can say they're perpendicular. If the answer is neither one of those, I'll say it's neither. So let's find out what it's going to be. Let's see what we've got. Y equals 6/5 x plus 4. Now, assuming we didn't make any sign errors, which I don't believe we did, we see that since these two slopes are not exactly the same, that these lines are not parallel. Now, looking at them, these are almost going to be perpendicular lines. If one was positive while the other one was negative, I would say perpendicular. But since it's neither one, then we just say that these lines are neither parallel nor perpendicular.